Hi there, thanks for watching. This is the latest video in my Bearhawk saga. This is how I installed a trim system, a cable trim system in my Bearhawk. Bob Barrows, when he originally designed the Bearhawk, he put in a trim system which basically acts as a servo tab. Whenever you move the elevator up, the trim tab goes down, the elevator goes down, the trim tab goes up. In effect, it gives it a power boost or power assist. Some people complain that it gives it a little bit more, too much authority in the pitch axis. If you Google Anton Flettner, he was a German aeronautical engineer in the early part of the 20th century. He's the one who invented the servo tab, and specifically for helping move heavy control surfaces, giving a little bit of a power boost or power assist. And some people think that it gives a little bit too much authority in the Bearhawk. Pat Fagan thought that as well, and he came up with this basic idea of this cable trim system, which is more like conventional aircraft where you just move the tab and then the tab stays in the same position relative to the elevator regardless of the position of the elevator. So looking up here in the cockpit, the original trim wheel position, you can see there's a cog on here. That's the design. You would have two tubes welded through the front spar carry through, and then a couple of other tubes there that would capture a bolt, and then it would just, this trim wheel would pivot on here, and then you would actuate the trim cables. What I ended up doing is taking a trim system out of a mall and adapting it here to the Bearhawk. This is, like I said, this is a mall trim wheel. Normally in a mall it sits vertically in the floor, but you can see also that it's geared. I thought this would be a really good idea for having this trim system in the Bearhawk. First off, this trim wheel is very large, has a nice lip on it. You can grab onto it very comfortably in the cockpit, and you can have gloves on, you can still operate it, and it has one less obstacle in here like the vertical wheel would have to hit your head on in case of an accident. You can see here on this gear there's two little weld marks. They correspond to some little nubs that are welded onto the bottom of the gear, which provide a mechanical stop for the trim so you don't end up actuating it too far. So if you look at it, rotates once, the cog goes less than a quarter of a turn, but it goes all the way around until it hits a mechanical stop. Second way, all the way to the mechanical stop. Going back here a little further, here's the trim chain, swedge fittings for the 1/16 cable, going through some fair leads on the top of the fuselage, going inside the fuselage here at this point. Coming back to the first bell crank, this is very similar to what Pat Fagan designed. The shape is almost identical to his, however the mounting is different. Pat Fagan mounted his bell crank with two angles that were welded horizontally in relation to these vertical tubes and then put a bolt through. I went ahead and used a little bit different idea here. I went ahead and used a little bit of a cantilever tube here, and on the back side you can see there's a strut. It also welded on to help stabilize it. It doesn't really need much because this is very stiff, just being welded on, but I figured that couldn't hurt to have a little bit extra rigidity back here. The bell crank itself is identical to what you see in the wing bell cranks for the ailerons. There's two R4FF bearings, one on top, one on bottom, captured with this bolt. We go back here to these cables. These cables are regular control cables for aircraft. They're 6 feet long. They're used commonly for prop controls or even throttle control. They fit in a keyway, and you can see in this little bulkhead fitting that I made back here that there's a keyway, a larger hole where the cable passes through, and then the cable slips down into a slot and then gets captured by these two lock plates on the back. RV builders use cables that are similar, but they're a bulkhead pass-through cable where you just drill a hole and there's a nut with some, and then this part is threaded, and you just drill a hole, thread the nut down and lock it down in place. That would have been a lot easier to use than these cables, but since I bought these already and it was too late when I found out about the other cables, I just went ahead and went with it. So we'll go back to this little spreader bar here at the last. Moving on back here, we'll start at the aft end of the elevator and go forward. Nice to have a fuselage on rotisserie. Here's the trim tab itself. This is the original position of the actuating arm here. I made another arm, cut this one out, moved the arm inboard, welded it to the inside rib here. If you can see, there's two holes here. Those are just so I can drizzle some epoxy paint in here to help eliminate corrosion, because I effectively blocked off this one little rib here. I want to make sure it gets paint in there to make sure there's no moisture problems later on. Looking back here also, this arm, you can see it's been reinforced. I cut off the end of the old arm that I cut off of the trim tab here and welded it on here to give it a little bit more meat. There's 3 holes here. They're all relatively close together, and it'll just help keep it from wallowing out with use. Hopefully I'll have that problem. In other words, I'll be flying this thing at one point in time. So tipping it up a little bit further, you can see the elevator itself. Here's the mount where the cable goes in. The cable itself can rotate 360 degrees in a little bit of an arc. It'll go like this. It's got a little bit of a gimbal mount here, a little bit of a gimbal underneath this dust cover, so it does allow it to go down like this. It's about at its limit, but that's okay. It's designed to do that. Here's another fitting here on the rib for the elevator, where the little key slot again allows for the cable to be mounted. And then here's a picture of the little locking tab that I use for locking the cable in place. Goes forward. Another feature of this installation. At first I drilled a hole and put a grommet here. I didn't like that because it really put stress on the grommet in a weird way, because the natural cable sweep is at an angle. So I went ahead and welded in a piece of 1/2 inch tubing to help as a guide, and it follows the natural sweep of the cable. And here's also an Adele clamp to help keep the cable in place. Now the reason I did that is because how many times am I going to be pulling fabric off this thing to do an inspection? I wanted to basically do a build it and forget it feature almost for this trim cable. So I wouldn't have to worry about it when the fabric's on that something's going to let loose. The real issue here between, although the front and the back were easy to build, all the movement occurs right here between the elevator spar and that front bulkhead. What I did was to put the cable here and have it in a good spot. At first I used a piece of safety wire and safety wired it to the elevator spar, but it rubbed when I moved the control surface up and down. The cable rubbed on the elevator spar, and also it got real close here to this control horn here for the elevator. And also I couldn't control the position relative to the elevator cables themselves, so there was always a danger of it rubbing, and also with the fabric, because there's going to be fabric on each side. So first off, what do we do with the cable when it exits the control surface itself? I got a piece of 3/8 inch tubing, put a curve in it, cut it in half. Then I welded on some little nubs on the end to help keep the safety wire from slipping off. And then I had the angles just right on each side, left and right. So now when the elevator goes up and down, you can see it doesn't stress the cable at all. It keeps a natural sweep, and then it keeps it from rubbing on the elevator spar. So the last part, let me put the fuselage back up straight here. Got to get up on the end. Last part is what do we do with the cables that are back here fighting for space with the elevator cable itself. Well, I made this little spreader bar with some Adele clamps, and then also for shock absorption and for just control of the cable position, a couple of springs that help keep it centered. You can see that vibration. It allows for the cables to move a little bit to not stress them. You go full up elevator. It is fully extended, full down, and it keeps the belly and the cables in a controlled position, and the springs just really help position the cables in a good spot and keep them that way throughout the movement of the elevator. It's not going to be that big of a deal in flight. You're not going to have the cable move that, or the cables move that much, because the elevator's not moving that much, but it does allow for shock absorption, also a natural way for the cables to avoid the fabric and also avoid the elevator cables themselves. So that's it. Thanks again for all those people that helped with some ideas, and I hope it was useful to you. Till next time. There we go.